Hello, welcome to the homework help video for homework number 19. This is page 2 of the review for the upcoming RCA required course assessment quiz that is happening soon. Okay, so let's go ahead and start. This starts with problem number 5. We did the first 4 problems on page 1, and there's 3 more on page 2. So here we go. Express as a trinomial. That's a big deal. In standard form, must show all work. That means I need to see all steps in order for you to get full credit for this. This is a problem on your quiz that will be worth a few points. So if you just have an answer and no work, only if the answer is perfect, you might get a point for it. But if there's anything at all wrong with it, you get nothing. So make sure you show all your work. Okay, so the first step would be to, in my opinion, well, it depends. I think I might actually go in a different order than I did on the original key that I made. No, maybe not. I was going to distribute the -3 first. But I think maybe I guess I'll start with the 2 binomials and do the double distributive. You could, and I'll set this up over here, do a geometric area model if you are somebody that prefers that strategy. Okay. And it might look like this. Put an arrow over here. You put one binomial as the length and the other as the width and fill it in. But I'm actually going to, so I set that up for anybody that prefers that strategy. I'm going to do the double distributive. So first distribute 6x to both 7x and 2. I'm not going to distribute the 6x all the way across. These parentheses are together. Then they're separated by that subtraction sign. That means you don't continue distributing through the rest of the polynomial. So 6x times 7x is 42x squared. 6x times 2 is 12x. Now, let me switch colors here. 3 times 7x is 21x. And 3 times 2 is 6. And then I'll write the remainder of the polynomial, minus 3 parentheses x squared plus 6. Okay, so next step, now I'll distribute this -3 to everything in parentheses here. So I still have 42x squared. I still have, you know what, I could probably combine these like terms because they don't impact this over here. That's 33x plus 6. And now -3 times x squared is -3x squared. And -3 times 6 is -18. Double check with your calculator if you want to be sure. All right, now it's a matter of combining like terms, CLT. 42x squared goes with -3x squared. 42 minus 3 is 39x squared. I hope I didn't make a mistake. 33x does not have any like terms. And positive 6 and -18 combine to give me -12. And this is a trinomial, and it is in standard form, so I am done. My answer key that I provided that you'll see posted with the assignment has a little more work than what I just showed, but you would need to show at least probably 3 steps here to be able to get full credit for this. All right, that's it for problem 5. I'll pause the recording and meet you at problem 6. All right, here we are. Problem 6, fill in the blanks of this proof with the complete name of the property that justifies the changes in the algebraic expression from the line above. distributed property, associated property of addition or multiplication. Yes, you need to say which one. Do not just say associated property. You also have to include addition or multiplication. Commutative property of addition or multiplication. Same thing there. With the distributed property, you can just say distributive property or distributive. Okay. The first one is actually horizontal, and then the rest of them go down. So you can even see the arrow right here. Okay. So to go from this step to this step, the only change I see is I have this little negative sign here that seems to be in front of the parentheses, but then looks like it's getting distributed to everything in the parentheses. So the first blank is distributive property. You know what? I'm not going to use my writing tool there. I am going to use my typing tool so I can do this faster. Okay, distributive property. Okay, so that's the first one. Okay, next we're going from this expression, or excuse me, equation to the one below. And the only change I see here is the 5 is behind the parentheses, now is in the front. When you change the order, remember CO, change order, that is commutative property. So actually, just let me show with just like a little arrow here that what we're doing is switching those. You know what? I wonder if I can grab this guy here and move it over. Oh, that's not working. There we go. Put the arrow there. Get it out of the way. All right, now I can type in my answer. Commutative property. Now, there's no math symbol in between the 5 and the parentheses, so hopefully you remember it's multiplication. You only have 2 choices, multiplication or addition, so that one's clearly multiplication. Now from this step to this step, hey look, we're switching the -3 and the 7x. Trying to put it in standard form. And what that means is I'm doing the commutative property again because I'm changing the order, but this time it is addition. Because if you look in between the -3 and the 7x is an addition sign. Okay, from this step to this step, what is happening? Well, now it looks like we are switching all of this with this. And there is a symbol in between. It's that addition sign. So basically, I'm doing the commutative property of addition again. I would allow you to just type or write the words commutative addition, commutative multiplication, if you want to leave out property of. And then for the last step, to go from here to here, you notice the parentheses disappear. What does that mean? I'm distributing the 5. Hopefully it is done correctly. I'm kind of flying through this. Distributive property. All right. Hopefully you understand why those are the correct properties. If you don't, make sure that you study those or ask questions. And I'm going to pause the recording and meet you at the last question on the back. All right, here we are. Using the graph below that illustrates a student's trip to their locker to get a pencil for their algebra test, answer the following questions. So here we have distance in meters, time in seconds. Oh, by the way, this graph is missing something. It is missing a title. So if you watch this video and you mention that in class, that it's not, well, yeah, it is a mistake, isn't it? We're missing a title. I'll just put distance versus time, although that's not a good title for this one because we know what the graph represents. Mention that and then you'll get a couple of points on your scoreboard. All right, part A, what does the origin mean in context of the situation depicted in the graph? So the origin is 0, 0. 0 distance, 0 time. What does that mean? Well, the student starts in their classroom. You know what? I should probably pause the recording and type the rest of this and then explain it. All right, I'm going to do that. In a split second, you're going to see the rest of the answer, and I'll talk about it. Okay, I was having some technical difficulties here, so I didn't get the rest of this typed in, but that's okay. Let me finish it here now. So they start in their classroom, and we have 0 distance and 0 time. Okay, so now I'm going to pause the recording and answer the next one, but that is basically all you have to say for the first one. When you start at 0, 0, that's where they are. They're still in their classroom. They haven't gone anywhere, and there hasn't been any distance yet. Okay, so in a second, you'll see the answer to part B, and we'll talk about it. Okay, part B, which section shows the student returning to the classroom? Explain how you determined your answer. So I'm going to look at the graph. So when I'm thinking of returning to the classroom, they start at the classroom and the distance is 0. So I'm looking for where this graph returns back to 0 distance, and it's basically all the way here at the end at point D. So you could say the interval C to D, or 90 to 100 seconds, or at point D, because the distance returns to 0. That is the basic, explanation for this. By the way, I want to point something out about this graph. Sometimes when students read this situation and they start looking at it, they say, oh, well, this part here from O to A is where a student, or 0 to A, a student is going up some stairs, and over here they're going up some steep stairs, and here they're sliding down the stairs. No, this is not an elevation. This is a distance. So if you see a problem like this and you start talking about going up or down stairs, you are way off, all right? This is about how far away they are from their classroom. And we're going to talk about the last question. Actually, I'll pause the recording, put the answer, and we'll talk about it, and we'll be done with the video. Okay, part C, describe a scenario that represents what the student is doing in interval AB. So I'm going to go up here, interval AB, from 40 to 70 seconds. That's this part right here. Okay, I'll even circle it. So what could be happening? Well, the distance is not changing, but the time is. So basically, the student is stopped somewhere. Where are they stopped? Well, this is what I said. So the distance, 6 meters, does not change, but the time does. 30 seconds go by. The student could be at their locker getting the pencil they need for their test. That is the whole reason that they left the classroom, was to go get a pencil for their algebra test. Some of you might say, well, maybe they stopped to get a drink of water, or maybe they did something else, whatever. That's fine. Okay, but what you have to indicate is they're stopping somewhere for some reason for 30 seconds. And notice I did put some of the data and information from the graph in my explanation. That just further supports what you're saying, okay? Very important. All right, that's it for this video. A little bit longer than it needed to be, but hopefully this helps if you need it. Good luck, and we'll see you in algebra.